So, noble gases. More information about your periodic table. Noble gas stability. Why are noble gases so stable? And then I wrote here, if you look at your Bohr diagrams, what's different about them. Really, what I'd like you to look at is where they are on the periodic table. Where are the noble gases on the periodic table? What row number are they? 18. They are at the end of the periodic table because that's when they have a full valence shell. The reason they're so stable is they have a full outer electron shell. They don't need to gain any electrons. They don't need to lose any electrons. They're happy just the way they are. They're happy just the way they are. It says answer on your worksheet. There's going to be a worksheet later on where you get to answer that. So, noble gases have full valence, which is the fancy word for outer, but I'm going to use the word valence from now on. Shells. So they can't lose or gain electrons. Aside from that family number 18, the noble gases, all the other atoms on the periodic table want, now I put the word want in quotation marks because atoms aren't alive, they really don't want anything, but this is where they're, quote, happiest, where they're most stable, okay? All the other atoms want a full valence shell. And they will lose or gain electrons in order to get it. So find chlorine on your periodic table. What element number is chlorine? 17. So if I zoom in on mine, there's chlorine right there. Now there are two ways that it could get a full valence shell. If you count over from the left, how many electrons does it have in its valence shell? Count carefully. 7. Okay, all you do is count. 1, 2, 3, 4, 5, 6. Chlorine is the 7th element in that row, in that period. So how many electrons does it have in its valence shell? 7. So it could lose 7 electrons. That's one way it could get a full valence shell. Or how many electrons would it need to gain to get a full valence shell? Just 1. What do you think is easier, losing 7 or gaining 1? So chlorine will want to gain 1 electron. In fact, all of the nonmetals on the right-hand side, they want to gain electrons, which is why they're not conductive, because if you send electrons nearby, they're going to grab onto them and glom onto them and hang onto them. All of the metals on the left-hand side, they want to lose electrons. It's easier for them to lose electrons, which is why they're conductive. They're very happy to send electrons through. So how can it most easily get a full outer shell? Add 1 electron. I don't think I have that part in your notes, do I? Anything in red is usually a thought experiment. What about calcium? Find calcium. What element number is it? 20. 20? So calcium for me is right there. What element number is it? 20. How many protons does it have? 20. How many neutrons does calcium have? Do the math. Also 20, 40, minus 20, 20. How many electrons does it normally have? It normally has 20 electrons. How many electrons does it have in its valence shell?
18.
No.
Valence shell
1, 2. That's all it's got. Count from the left over. That tells you in that final shell how many there are. It has 1, 2. It would love to get rid of those 2 electrons. If it loses 2 electrons, it's lost 2 negatives. So how many positives is it now? Losing 2 negatives is the same as what? That's why it says 2 plus right there. Its ion charge would be 2 plus. It wants to lose 2 electrons. Where, remember chlorine, what chlorine was over here somewhere? It wants to gain 1 electron. That would add 1 extra negative. That's why its ion charge right there is minus 1, minus. Phosphorus wants to gain 3 electrons to get an outer shell. That's why its ion charge is 3 minus, because when it's stable, it's got an extra 3 negatives. Compare that with scandium. It's most stable when it loses those 3, 1, 2, 3 outer electrons. It wants to get rid of those 3 outer electrons, and that's why it has a 3 plus ion. It's most stable when it's got a charge of positive 3, when it has 3 fewer electrons than protons. There's a lot of information there. Let's go back to our notes. What do you notice about the number of electrons lost or gained in the ion charge? This is the number in the upper right corner of the box. So the number of electrons lost or gained almost always corresponds with, for the metals, how far over from the left-hand side it is. For the non-metals, how far away they are from the noble gases. Full electron shell, full valence shell. It says answer these questions on your worksheet. You'll be doing that a bit later. So, atoms can become ions. An atom that has lost or gained electrons has a charge. And that is called an ion. Atoms are neutral normally. Atoms have the same number of protons and electrons. Ions are not neutral. They have a charge. They can be positive or negative. The charge that forms is shown in the upper right corner of each box of the periodic table. So find strontium.
Okay.
Element number what?
38.
38. See it there? Okay. Find it, Jimmy?
No.
Element number 38.
Oh, found it.
Okay. Element number what, Jimmy?
38.
How many protons does it have?
Is that the all 30?
Okay.
Is that-
38. How many electrons does it have when it's neutral? Still 38. How many neutrons? That's going to be the mass minus 38. 50. 88 minus 38. 50. Now, what about when it becomes an ion? How many electrons does it want to lose? There's several ways to figure that out. You can look at the ion charge here. The fact that it says 2 plus means it wants to get rid of 2 negatives. It wants to lose 2 electrons. By the way, it's a bit confusing because you might want to say, doesn't 2 plus mean it wants to plus 2 electrons? But what's the charge on an electron? They're negative. So a 2 plus means it wants to get rid of 2 negatives, 2 electrons. The other way, Al, you can figure that out is simply counting. Look up. 1, 2. There's a reason strontium is in that second column. It's because its valence shell has 2 electrons and it wants to get rid of those to be stable. Okay? When you're drawing a Bohr diagram of an ion, we draw the Bohr diagram and then we add or remove the electrons as necessary. And then to show it's an ion, we put square brackets around it. And then we indicate the charge outside the brackets in the upper right-hand corner. We're going to do a practice one right now. So if you want to get out that sheet that I gave you with all of those circles on it, the one that says drawing board diagrams practice or something like that. Chemistry joke. Am I keeping my eye on you? Okay. And then I think I said in your notes, we're going to draw a Bohr diagram for an atom of sulfur. Then we're going to draw a Bohr diagram for an ion of sulfur. So let me go to my copy of the... Nope, I want this one here. Okay. So let me zoom in a little bit. In the first little circle there, we're going to draw an atom of sulfur. Generally what I do is I put the chemical symbol underneath it. Sulfur is S, yes, I think?
Yeah.
Find sulfur.
6.
Okay. What element number is it? 16. How many protons? So here in the nucleus, I'm going to write 16p plus for protons. You can't try and put 16 dots. They're so small. We're not that fussy, Julia. We don't do that. How many neutrons? Mass minus protons. What's the atomic mass of sulfur? Is it 32? Okay, so 32 minus 32. 16 neutrons. Now I'm going to start to work my way outwards, filling in the shells. What period is sulfur in? First, second, third, fourth, fifth? Third? No, period. Going down. Third? Yes? I'm going to ask you the same question. I'm just going to phrase it differently. How many shells will I start to fill in? 3. So let's start with the innermost shell. How many electrons can that hold? And it's full, and we pair them up. Why do we pair them up? It's a quantum physics thing that has to do with spin and weird things, but I'm just going to say pair them up. Kuchum, we move to the next one. Is the second shell also full? Well, yeah, because you told me that it has 3 shells, so that second shell is full. How many electrons can we fit in that second shell? 8. What if you forget? Count how many elements there are in the second period. There is 8, so it's going to look like this. 1, 2, 3, 4, pair, 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 pair. That's going to be the pattern that we're going to use when we fill in electrons. Third shell, the valence shell. How many electrons does a sulfur atom have? You're going to figure that out by counting all the way across from the left. How many? 6. So it's going to look like this, Quentin. 1, 2, 3, 4, and then pair 5, pair 6. I don't care where you put those last 2. They just have to be paired. So if you decided, Helia, to put them like that, I'd be okay with that as well. If you decided to put them right there, I'd be okay with that as well. I just tend to start at 12 o'clock and go around clockwise. That is a Bohr diagram of a sulfur atom. By the way, again, that's not what a sulfur atom really looks like. It's a model, but this will explain an awful lot. Now, we're going to do a sulfur ion. What's that going to look like? I still put a letter S. I still put 16p plus and 16 and neutrons and protons. We don't muck around with those. Those do change. You'll learn next year when you look at radioactivity, but this year we're going to pretend they don't. Innermost shell still has 2. Second shell still has 1, 2, 3, 4, 5, 6, 7, 8. Now we have to pause and think. Does sulfur want to gain electrons or lose electrons? Wants to gain. How many?
2.
So that outer shell is now going to be completely full. So I'm going to go 1, 2, 3, 4, pair, 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 pair. Now it would have taken those electrons from an atom that wanted to get rid of electrons. A metal, usually. Here's the problem. Right now, if I was looking at your diagram, I might think that you just made a mistake. To show that we did this on purpose and that it's an ion, we then put a great big square bracket like that. And in the top right corner of the square bracket, we write the ion charge. What's the ion charge? So, we write 2 minus, because I think that's how it... if you wrote -2, I wouldn't take marks off, but I think on the way it is on your sheet is 2 and then a minus next to it. Yes? On the periodic table? And that's how I would know that you meant to draw it that way with the extra electrons. That, Jordana, you're telling me, it's an ion. It's gained electrons. It's stolen electrons from some other element that wanted to get rid of electrons. Okay? You are absolutely going to... Oh, you know what? I would normally say it this way. I like this question. I like this question. I like this question. Connor, why would I say that?
It's on the test.
Did you hear me say it's going to be on the test? Or you tend to notice when your teacher emphasizes certain things? Okay? There are Bohr diagrams of atoms and ions in your future. Now, let me be clear. I'm not going to give you 40 of these. on a test or a quiz. Too much work. And I'll even be more blatant than that. It's almost certainly going to be in the first, second, or third period. Because how many electrons are there in the fourth period? Now, I might do potassium or calcium or scandium because that only requires adding 1, 2, or 3 extra dots. But I'm never going to ask you to draw selenium because that's 16 dots. That's overkill. I'll assume that if you can put 8 dots in the right place, Brianna, you can handle 16 if I threw it at you. I'm not going to go that far, though. Is that all right? Yeah? Okay. Oh, back to our notes here, Mr. Dewick. Okay, so we drew a Bohr diagram of an atom of sulfur. We asked how many electrons would it lose or gain to form an ion. We drew a Bohr diagram of an ion of sulfur. We remembered to make sure it had a full shell because that's what an ion has. And then we said we're going to do square brackets and we're going to add the ion charge. Nonmetals form negative ions because nonmetals want to gain electrons. Nonmetals want to gain negatives. So if nonmetals form negative ions, what do you think metals form? Are you positive? Are you? Oh, okay. Not really, but it works. Now, some atoms, metals in particular, can form an ion in multiple ways. Find copper on your periodic table. Element number 29. How many valence charges, how many ion charges does it have? 2. There are 2 ways that it can be stable. It's stable sometimes when it's a 2 plus and sometimes when it's a 1 plus. Why is that, Mr. Dewick? Because this model that I'm giving you of atoms as little circles with electrons moving up is wrong. They're 3-dimensional and they overlap and they twist, and so as you go further out, weird stuff happens. I'm not going to get into that. If you're bored sometime, you can do a YouTube search for P shells and Q shells and S shells and learn about more specifically, more correctly, how electron shells form. All I'm going to say is some metals are multivalent, is the fancy schmancy way we say it. Iron is multivalent. What's the first one, the first valence charge that iron has? Find iron on your periodic table. Okay? That's the most common one. The second most common one is the 2 plus. There are some that are on that can occur that aren't listed. In fact, you can also do a 1 plus if you under the right circumstances in the lab. It's very rare. We didn't bother putting it on your periodic table. We're going to draw a Bohr diagram of an aluminum atom and an aluminum ion. You know what? Let's do them on that sheet that has all the circles on it. So we're going to do aluminum, the atom first. Aluminium, thank you. It's really how it should be pronounced. Okay. So I'm going to do it right here. Al. You can call me Al. What's its number? I'm going to ask you the same question. I'm just going to phrase it differently. How many protons? 13. So 13 protons. How many neutrons? 14. Oh, 14. 27 take away 13. Let me pause. By now, you need to know how to find protons and neutrons. There is going to be a quiz in your near future that's going to ask you those questions. If you're still not sure on how to do that, you need to come in for a flex and I can help you with it. How many shells is it going to have? Is it third period? So first shell, 2. This is why I said some kids memorize the 2, 8, 8, 18 rule because it's less thinking. But second shell is full with 1, 2, 3, 4, 5, 6, 7, 8. In that valence shell, how many electrons in the valence shell? Count over from the left. I'm also guessing there's a little 3 plus in the top right corner of aluminum on the periodic table. So you got 2 ways to get that. You can count, but also, Amy, it's there too. So 1, 2, 3. Okay. By the way, what if I gave you one more shell? You could just add that final circle freehand if you needed to, but rarely will I go that big. That's an aluminum atom. Now let's do an ion. We still write Al. We still have 13 protons. We still have 14 neutrons. We still have, Helia, you're right, 2. And we still have 1, 2, 3, 4, 5, 6, 7, 8. Now, aluminum, how many electrons does it have in its valence shell normally before it becomes an ion? 3. It wants to get rid of those. So, in the next shell, how many electrons are left once it gets rid of those? I'll give you a hint. It's a trick question. What? In other words, I'm done. I'm not going to be adding more electrons. Aluminum ions have how many electrons? 11. Sorry, 10. 10. Aluminum atoms? 13. Aluminum ions? 10. Oh, did I say ion? I want to make sure the marker knows I did this on purpose. So I put the square bracket like that and like that. And I put the little ion charge right there. That tells whoever's looking at my diagram, no, I didn't count wrong. I meant to draw it this way. It's an ion. Is that all right? You're going to be doing a bunch of these in your homework as well for practice. Let me pause. Paige, is that okay? Some deep stuff we've been going through here. I know. Heavy-duty stuff. Back to our notes. And where's my PowerPoint? Right here. So, valence electrons. I've already snuck this word in as many times as I could. Usually if I keep repeating a word, you can bet that'll be a vocabulary word somewhere in the future. The electrons in the outer shell are called, what's the special word? Begins with letter V? Valence electrons. And they determine if and how an atom will react. Why don't the noble gases react? Because they have full valence shells. So they're stable. They don't need to gain or lose electrons. To determine the number of valence electrons, count over from the blank side of the periodic table. What word do you think goes there? Left side. I have to lie a little bit. This only works for the first, come here, Mr. Duke. First 3 periods. After that, it gets a little weird. You know what? After that, remember that all the members of a vertical column of a family have the same number of valence electrons. So, fluorine, chlorine, bromine, and iodine all have 7. Now you may say, hey, wait a minute, Mr. Duke. When I count over from iodine all the way over here, I get 17. This is why I said it gets a bit weird as you go further down. Electron shells start to overlap and intertwine. Much of what I'm teaching you is wrong. This is a model. Works pretty good for the first 3 or 4 rows, first 3 or 4 periods. So really, if you want to know how many valence electrons anything has, it'll have the number of valence electrons that the thing has above it in the 1, 2, or 3 rows. So, very quickly, how many valence electrons do each of the following have? How many valence electrons does magnesium have in its outer shell? Find magnesium on your periodic table. How many valence electrons does boron have in its outer shell? Find boron on its... 3? Boron? I think 3. 1, 2,
Oh.
1, 2, 3. Yes?
Yeah.
Okay. How about chlorine? No, 7. 8 would be the far row. The noble gases have 8. How about selenium? Got to find it first. Okay, so you might be tempted to say 16, but if you
2 minus.
slide up to the very, very tippy top. Okay, here's why. So for the first 3 rows, this will be accurate. When you get to these guys here, the shells start to overlap, and the trick is to just go and look at what the very, very top one has. It has that many in its valence shell. Okay? Now, let me say again, Helia, on your tests, I'm going to be almost always staying in the top 3 rows, but I'm covering the weird stuff. Tin. Symbol is SN, I know that. Element number what? 50. So you're not going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 8.
4 apparently.
Four, 13.
14.
Gallium.
Where you at, bud? Oh,
What element number is gallium?
31.
31?
3.
Okay. And it's the fact that these electron shells mentioned overlap and intertwine. That also explains why we had to kind of carve a gap right in here and fit a whole bunch more, and that just wouldn't fit on a piece of paper. So you can imagine this bottom row, second from the bottom, fits right in there, and this very bottom row fits right in there. But that would have your periodic table going out past the edges of the paper. So there's our workaround.
What would iron?
Iron.
Here you do those. I do the middle ones.
4th row still works. You can count, actually. I wasn't consistent. 1, 2, 3, 4, 5, 6, 7. Iron has 8 in its 18th shell.
How would you do the middle ones in the bottom?
We're not gonna. The short answer is that I avoid asking you questions about those because our rules start to break down. Marco, you're not on your phone or anything foolish like that. That would be silly. Right? Right. So, now that I've gotten this far, last day I handed out homework. I think you can answer. You don't have to worry about doing chapter 2 review or anything right now. I think you can answer those, and then on your notes you have some questions to answer. Yes, on the very, very last page.
Yes.
And I didn't give you the answers. That's going to be kind of a practice quiz. I'm going to be going over the answers with you next class. Okay? So you got a half an hour to finish section 2.3 homework. You got a half an hour to finish these questions here. And draw some of those diagrams. Okay? We're basically done the chapter, but I've thrown so much at you. The next couple of days, we're just going to practice this and practice this and practice this and practice this. If you're wondering, right now, I'm thinking your chapter test is going to be maybe a week from Wednesday or the following Monday. Okay? But I'll let you know in more detail. I emailed out an update on Saturday, so if you're wondering what you're missing, Jimmy, you with me?
Diane.
No, you're not. Put whatever it is away.
But I like
Okay. If you check your email, you should find out anything that you're missing.